Today we will talk about Book 4B, Chapter 12, more about basic properties of circles. So in the previous videos, we talked about the cyclic quadrilaterals, the opposite angles, the exterior angles, and the test for it. And today we will talk about a little bit something else. Okay, so today we will talk about tangents. So what is tangents? So if we got a straight line and a circle lying in the same plane, there is only three possible cases. They either intersect or they don't. So the first case is they do not intersect, and then the second case is they intersect at only one point, and then the third one is they intersect at 2 points. And in this case here, we will look at case 2. So case 2 is the one we want to focus at. So in this figure, the straight line PQ touches the circle at only one point, T. And in this case, we will call that PQ is the tangent to the circle at point T. And point T is actually your point of contact. So keep in mind that only one tangents can be drawn through any point on a circle. So we'll actually look at the relation between the radius and the tangents. And in order to do that, you can have a look at your textbook, page Ch.12.3A. Okay, or you can have a look at this one here. So in this figure, I got a circle. And you can see this line here intersect the circles at 2 points, point P and Q. And supposedly, if I rotate this line, I rotate this line clockwise about the point P, and then you can see my point Q is getting closer and closer, and then the angle here will eventually become 90 degrees. So this line here becomes a tangent to the circle at point P. So this is our tangent. So the theorem we're going to learn in this part is if the AB is the tangent to the circle at point P, then we can always say that AB is perpendicular to OP. And the reason for that is the tangent is perpendicular to the radius. And then, of course, we have a converse of this theorem as well. So if we want to test whether the straight line is a tangent to the circle or not, we can use the converse of tangents perpendicular to radius. So therefore, if you find that APB is perpendicular to the radius of OP, then you can say that AP is the tangent to the circle at point P. So from the theorem 6, we can deduce that when a straight line is a tangent to a circle at a point, the perpendicular line to this tangent at a point of contact must pass through the center of the circle. So you can see there's a little proof at the bottom, so you can have a look at it. And I'm not going to go into very detail of this part, but you can have a look at it yourself. So let's go to our example 8. So how are we going to use this theorem? So in this figure here, PR is the diameter of the circle, and then SQ is the tangent to the circle at Q. And they give you the angles 26 here. So tangent to the circle at point Q, and they ask you to find QSR. So let's look at where's QSR. QSR is this one here. Okay, so what do we know about this shapes here? So we know that the tangents, SQ is the tangent to circle at Q. So meaning that your OQS is equals to 90 degrees because of the tangent perpendicular to radius. So this is what you have just learned. So this one is 90 degrees. And this is a circle, so that you know that this OQ and OP is actually a radius. And if they are the radius, then it means that these lines are the same length. And if they're the same length, this angle is also 26 as well. Right? So therefore, let's write down. So because OP is equals to OQ, radius, and therefore OPQ is equals to OQP. base angles isosceles triangle. And so if we know this is 26, this is 90, how do we find this? This is a triangle here. So all the angles inside add up to 180. So in the triangle PQS, angle PQS plus angle QSR plus angle OPQ equals 180 because angle sum of triangle. So you try to add those up, and then the only unknown is your QSR, which is the one you want to find. So 26 degree plus 90 plus QSR plus 26 equals 180. So therefore, your angle QSR is equals to 38 degree. So if there's no problem, we will look at the other question. So example 9. So let's look at this figure here. The chord AB cuts the radius OP at point M, and then AM equals BM, and then they also give you a parallel line as well. AB is parallel to PC. The first part asks you to find theta. Okay, so what do we know about theta? So look at the information you have first. Okay, so here you have this two line is the same length, AM and BM is the same length. And if this is the same length, we can say that OM is perpendicular to AB here. Okay, so let's write it down first. So AM is equals to BM, and therefore they are perpendicular. And the reason is your line joining center to midpoint of chord perpendicular chord. Okay, so therefore it means that your angle OMB here is 90 degree. So theta is equals to your angle OMB. Why is that? So let's have a look using another color. So these lines are parallel line because they provide it, and then therefore we use our corresponding angles AB parallel PC. So theta is also 90 degree. And it asks you to determine whether CP is the tangent to the circle at P. So if we know that this theta is 90 degree, so because theta is equal to 90 degree, so OP is perpendicular to CP, and therefore CP is the tangent to circle at P, using the recent converse of tangent perpendicular radius. Example 10. O is a common center of two circles. XY is a chord of the larger circle, and it is touching the small circle at M. So you can see that this is actually the tangent of for the small circle, and Z is the point of the larger circle such that O and Z are collinear, which means they're a straight line, and this XY here is 30 cm, MZ is 9 cm. So just write out first. And they ask you to find the radius of two circles. So meaning that they want you to find OZ and also OM. Okay. So what do we know here? So this is a this is a tangent. So because it's a tangent, we know that it is perpendicular to your XY here, And when this is perpendicular, we know that these two lines are equal length because xm and ym are the perpendicular from center to chord bisect chord. Okay, so what does it mean? It actually means that xm is half of your xy, which is half of 30, and that is 15 cm. Okay. So we now have more information, but the thing is, we still do not know what is our OZ, and we do not know what's our OM. So how can we find it? So using the information you have got, and maybe if we add this line here, it will make things more clear. So draw out here, XO M. So we got a right angle triangle here. So with this right angle triangle, we know that this XM is now 15 cm, and we do not know what is this OX, and we do not know what is OM as well, right? But there is one thing we actually know. So OX, what kind of length is this OX actually? It's actually the radius of your large circle, isn't it? So therefore, it is the same thing as your OZ. So if we can find this OX, then we can find OZ. That's why it's easier if we use this information here. So this here, this OZ here, what is OZ? So perhaps we can maybe let an unknown R here. So let R be the radius. It's easier to write maybe. Radius of the smaller circle. Okay, so therefore, OX you can say now is equals to OZ because it's a radius, and therefore is equals to R plus 9 cm. So this part is R, and then you got the 9 cm here, right? And because it's a right angle triangle, then therefore we can use our Pythagoras theorem. So OM squared plus XM squared equals OX squared using our Pythagoras theorem. So R squared plus 15 squared equals R plus 9 squared. So R squared plus 225 equals R squared plus 18R plus 81. And here R is equals to 8 if you solve it. And then therefore OZ is equals to 8 plus 9 cm, which is 17 cm. So therefore your radius of two circles is 8 cm for the small one and 17 cm for the large one. So let's have a look at Consolidation Exercise 12C. Let's start with question 2. So question 2 here, TA is the tangent to the circle at point A. Find the unknowns. So let's look at the unknowns. So your unknown is here and also this one here. So if TA is the tangent, we know that this angle OAT is going to be 90 degrees. And also there's one more information that is provided. This one here is an equilateral triangle. So therefore, angle OAB and angle OBA and angle AOB is 60 degrees. So let's have a look. Seems like we have all the information already, so write down. So it equals to 60 degree. I'm just writing this one because you know that we only care about this one as it is this is part of your angle B. So therefore your angle B is 60 degree. And because this OAT is gonna be 90 degree, because of your tangent perpendicular to the radius. And therefore your OAB plus your BAT is 90 degree. So B plus C is 90. So 60 plus C is 90, and therefore C is 30 degree. Okay, if there's no problem, then we'll look at question 3. So question 3 again, AT is your tangent. Look at the unknown we got here and got here. So we know that this is going to be your 90 degree. So angle OAT is equals to 90 degree. Tangent perpendicular radius. And therefore your A plus 70 degree is 90 and A is 20 degree. So then you have to look at some other information in order to find B. So this here. So it didn't say that they are the same length, but because OB equals OA, they are the radius. Therefore, angle OBA is equals to angle OAB, base angles, isosceles triangle. So therefore, it's 20 degree. So now in that triangle, you have two information, so you can find the third one. So angle OAB plus angle OBA plus angle AOB equals 180. Angle sum of triangle. So 20 plus 20 plus B equals 180. So B is equals 140 degree. Let's look at question 7. Okay, so the unknown is here and here. And TA is the tangent. So therefore, we know that this part is going to be 90 degree. So let's write down. So angle BAC plus that H there is equals to 90 degree because of tangent perpendicular radius. So therefore, your angle BAC is just 90 minus H. We rearrange it. And then we don't have other information here, but remember, everything is inside a circle. So everything you learn from circle, you should be able to use it here. So let's look at this diagram and see if we have any other hints. So this BOC, maybe use another color so you can see it easier. So this BOC here is your angle at the center. And therefore, let's have a try and see if you can see any angle at the circumference. So because you know the angle at the center is twice at the angle at the circumference. So in this case here, we should be looking at this one. So BAC. Okay, so this one and this one. So angle BOC is equal twice at BAC. And the reason is angle at center twice angle at circumference. And then BOC, so because of this, so therefore, you can say that BOC is actually H, and then 2 of the BAC, so 90 degree minus H. And therefore, you can see H will be your only unknown here. So h, you can therefore find it as 60 degrees. So always remember, things inside a circle, you can use whatever you have learned so far. So how about let's have a look at question 9. So question 9, here we go. E is the unknown, and then TA again is the tangent, because at the very beginning they mention it. So all the questions we've been doing so far, TA's is the tangent. So in here, let's look at it, what we have got. So if this is tangent, we know that this is 90 degrees. And then they give you this information, these two lines are the same length. Okay, so how can we find angle E? So we don't have a lot of information, but we have a right angle triangle. So let's have a look at this. So because OB is equals to BT, then we can actually say that OT is equals to 2OB, this whole length here, right? And OA is equals to OB, which is given. Sorry, not given. They are radius. Okay, so always use the things you have. So these two are the same length. So they are radius, and then OAT is equals to 90 degrees. Tangent perpendicular to radius. So now you realize this length, you know that it's gonna be the same. This length is gonna be the same as OB. So OA is equals to OB, and OT is equals to 2OB. So actually, we can put everything in terms of OB. And it is a right angle triangle. So therefore, we can use our sine ratio and put those OA and OT in terms of OB. Then you will have this sine E is equals to 1 over 2, and this is your special angles, 30 degrees. So you can see this time we use our trigo ratios to help us a little bit. So how about let's have a look at question 10. So the unknown this time is not the angle, is the length. And then TA again is your tangent. So therefore, this here is gonna be 90 degrees. So again, you got this right angle triangle here, and let's have a look. So BA is a straight line that passed through your center point. So therefore, BA is your diameter, and therefore we know that the OA is the radius. So OA is equals to half of your diameter AB, which is half times 6, and that is 3 cm. And with that, we know this is 3. So now we got this length here, we got this little length here, and then we don't know what is this. But do we know what is OC? So OC is actually equals to OA as well. Why is that? Because it is your radius. So now we know that this is 3 cm. So we can see that we have this length here, using the other color maybe. We have this length here, we have this length here, and then we want to find the third length, and this is a right angle triangle. Then you will think of, okay, we want to use our Pythagoras theorem, but remember to write out, you know that this is your 90 degrees. Don't just draw on a diagram and expect that I know why you know that it's a 90 degrees. So always write it out. So now you can really use it and use your Pythagoras theorem to find your unknown. So OT is 3 plus 2, and then AT is k squared. So k squared equals 16, and k is equals to 4, or k is equals to minus 4, but a length cannot be minus, so minus 4 is gonna be reject. So make sure when you got a square roots of a number, they have a positive number and a negative number. Then let's look at question 13 here. So starting from here, the questions is about T is a point on a circle, PTR is a straight line. Determine whether PR is the tangent to the circle at T. So the previous question, we're using the properties of this tangent, and then now we have to prove whether it is a tangent. So therefore, it means that we have to show that whether that, for example, in question 13, whether OTR is 90 degree. If it is a 90 degree, then you can say it is a tangent. If it's not, then it is not a tangent. So let's see. If we need to prove that this is, if this is a 90 degree, so we need to find this angle here. So how do we find that angle there? So there isn't a lot of information, but again, this is a circle. So these two lines here is the radius. And because OT and OQ equals each other because they are radius, and therefore the base angles are equal. So base angles, isosceles triangle. And when they're equal, you know they're 28 degree, and therefore this OTR here is equals to your 28 plus your, wait a second, so is equals to 28 plus your 62. So 28 adding 62 degree gives you 90 degree. So since it's 90, you can say that PR is the tangent to the circle at point T. And this is the converse of tangent perpendicular radius. So how about look at question 15. So question 15 again is asking you whether it's a tangent or not. So therefore, we have to find this angle here and see if it adds up to 90 degree with the 65. So how do we find this angle here? So there is other information on the other side, and you can see this shape here. So therefore, we know we're going to use the angles in the same segment. So ATD is going to equals to which one? It's going to equals to your ACD, which is 20 degree. So they give that 20 and 25 there to make sure, just to check whether you can figure out which one is in the same segment. And therefore, you can say OTR is equals to angle ATD plus angle DTR. 20 degree plus 65, and it is 85. Then you realize it's not 90. So don't panic because they ask you to determine whether it is a tangent or not. So then for it doesn't have to be, it can be not the tangent. So it's not always the tangent. Determine meaning it can be yes or it can be no. But of course you have to always check your stuff. Tangent to circle at T. Okay. So this time this question's 15, PR is not the tangent to the circle at T. So how about we look at 16 as well. So again, prove whether it is a tangent or not. So we want to know whether this is 90 degree. So this time here, you got 36 in the same triangle with it, and probably you want to find this angle. If you find this angle, then you can use your angle sum of triangle to figure out whether your angle OTR is 90 degree. But how do we find this angle? Well, is there a is it gonna be the same segment again? So this time it's not gonna be the same segment, angles at the same segment, but this one is gonna be equals to twice the CAT, angle CAT, because it's angle at center twice angle at circumference. and therefore it's 2 times 27 degree and it's 54 degree. So in the triangle OTR, we can say that angle ORT plus angle COT plus angle OTR equals 180. Angle sum of triangle. So 36 plus 54 plus angle OTR equals 180. So angle OTR is 90 degree. So therefore, this time, PR is the tangent to the circle at T. And the reason is your converse of tangent perpendicular. So let's have a look at question 22. So in this figure, TA is the tangent to the circle A at A, and an angle AOB is 130 degree and BTA is 54 degree. So let's look at what they want you to find. They want you to find BAT, so which is this here. Okay, so based on the information they have given, seems like it's not enough, but look at this. Again, this is the thing you always have to look at. You got a radius, so OA equals OB, and then that is your radius. So what does it mean? It means that you don't just know this is 130, but you also can find these two angles here. So therefore, your angle OAB is equal to angle OBA because of base angles isosceles triangle. And in that triangle OAB, you got the 130. Therefore, you can use angle sum of triangle to find these two angles. So angle AOB, adding OAB equals 180. Angle sum of triangle. So 130 adding your angle OAB, and this one is OAB as well because they are the same, so it doesn't really matter which one you write. So 2 of the angle OAB is equals to 50, so angle OAB is equals to 25 degree. So you got that, and how can we find that A there, angle BAT? So it tells you that it is a tangent, and what do we know about tangent? We know that this here is going to be 90 degree, so that we can say angle OAT is equals to 90 degree because of tangent perpendicular radius. So angle OAB adding your BAT will be 90. And we've just found that OAB is 25 degree. So therefore, angle BAT is 65 degree. So let's look at part B. It says find ABT. So let's look at where's your ABT. So this one is your ABT here. And how can we find that one? So this one is actually pretty easy. So sometimes don't think that if you can't find angle part A, the answer from part A, don't give up, because you can see that this one, part B, is very easy. You got a triangle BAT there, and you already know what is angle BAT and you know what is BTA, so therefore you can find ABT by just using your angle sum of triangle. So part B is a little bit easy. So just write out. So 54 degree adding 65 adding ABT is equals to 180. So therefore angle ABT is equals to 61 degree. So look at question 29. in this figure here, ST is the tangent to the circle at point P, and if angle QPS is 50 degree and then ORQ is 70, find this PQR. So PQR is here. Okay, so this is PQR. So what should we do here? So first of all, we know that they tell you this is the tangent, so meaning that this is 90 degree, and if this is 90, then you can find this angle QPO already. So let's write down. So even though you don't know if it's gonna be useful, you can still write down. So tangent is perpendicular to your radius. So angle OPQ is equals to OPS minus QPS. 90 degree minus 50 degree equals 40. Okay, so what else do we know? We got a cyclic quadrilateral inside, but we don't have enough information to find this angle here because we don't have this opposite angle as well, so it's not going to be helpful even though you know it's a cyclic. And perhaps if we add one line here, it can help a little bit. So with the notation, so I'm gonna add this line here. So sometimes some diagram, you might have to add something to help you. So I'm gonna join this line PR together, and when you join it, you realize here. So you realize after I join, I think I just mentioned PR. It should be joining OQ. So after I join this line, you can see that this line is actually the radius. So OP is equals to OQ is also equals to OR because all of them are radius. And when you know this here, then it means that this is the length are the same, these two lengths are the same, so therefore you can see this angle and this angle because of the base angles isosceles, and at the end you add them up together will be your PQR. So let's have a look. So in the triangle OPQ, OQP is equals to angle OPQ, which is 40. Okay, because of your base angles isosceles triangle. And then in the triangle OQR, okay, your angle OQR is equals to angle ORQ, which is 70 because of your base angles isosceles triangle. Because here, remember your length, you tell me that those lengths are equals already, and then therefore angle PQR is equals to OQP plus angle OQR, which is 40 degree plus 70 degree, and it is 110 degree. Okay, so this is how you do this type of question. So sometimes you have to draw something on your diagram to help you. And in here, drawing a radius is helping you because you can see I create a isosceles triangle. And so let's look at question 45. Probably another question is that you might need to draw something. So let's have a look. AC is the tangent to the circle. So this is the AC. And when we talk about tangent, we know that it's perpendicular to the radius. Okay. And also, it gives you the length of OA and AC and asks you to find OC. And they also give you one more information, which is the ratio of AB to BC. So in here, with the notation, so maybe you might think, what is the line I have to draw? Actually, I have to draw the line already. The line I want to draw is OB. So why do I know I need to draw this line? because when they tell you about AC is the tangent, then you know that this line here is going to be perpendicular to your AC. And also, this ratio here gives you a hint as well. So they tell you that AB, this part, is to BC, the other part is 4 to 5. So you know that somehow you can use it as well. So in here, we got two right angle triangle, and they want you to find OC. So in order to find OC, and I only have some length, so probably I'm gonna use my Pythagoras theorem because it's a right angle triangle. But the first thing is, I don't know what's my OB, I don't know what's my BC. But can I find BC? Yes, I can find BC. Why is that? Because, I can find AB and BC as well. Why is that? Because we know that the total length of AC is 27, and then with the ratio, 4 to 5, so if we're finding AB, we have to use the ratio of 4 over the total ratio, and in this case it's 12 cm. And then for BC, we have 27 times the ratio 5, 4 plus 5 is the total ratio, and then you will have 15 cm. Or you can either, since you got AB already, you can just use 27 to minus it, and you can get the same answer as well. And because this one is 90 degree, and this is also 90 degree, and both of them is the tangent perpendicular radius. So I'm writing all this out because you know that in order to use your Pythagoras theorem, you have to show that you have a right angle triangle. So in triangle AOB, OA squared plus your OA squared equals AB squared plus OB squared. So OB is equals to square root OA squared minus AB squared, which is your 18 squared minus 12 squared. So square root 180 cm. So I'm going to keep it with the square roots here because it says leave the radical sign. And then OB is actually not your final answer yet. So once we have OB and we also have BC, then we can use our Pythagoras theorem again. So in triangle BOC, OC squared is equals to OB squared plus BC squared. And then therefore your OC is equals to square root OB squared plus BC squared. And then you have this 405 square root. Simplify your answer. So 405, you know it is 81 times 5, and therefore you can simplify it as this. So now look at our part B. It asks you that is triangle OAC a right angle triangle? So let's see where's your OAC. Okay, so this whole thing is OAC. Okay, is this a right angle triangle? How do we know whether it is a right angle triangle or not? In order to prove it, we can just see whether you can use your converse of Pythagoras theorem, which means I can check whether my OA squared plus OC squared equals my AC squared. So let's write it down. OA squared plus OC squared equals 18 squared plus your 9 square root 5 squared, and it is 729 squared. 729 cm square. And then AC square is your 27 cm square. And then you have this, so they are the same. So therefore, you can say OA square plus OC square equals AC square. And because they're the same, so therefore AOC has to be 90 degree, converse of Pythagoras theorem. And make sure you answer this. So therefore, triangle OAC is a right angle triangle.